He single-handedly, against Marcellus, who ran the Roman fleet at the time, single-handedly fended off the island of Syracuse. But he'd often just have a device. You've heard the phrase, give me a rock to stand on, and I'll lift the earth.
Yeah, or give me a lever big enough. Yeah, I've heard that.
That was his boast, because he built a lever system. He can operate himself. It was said that it reached out in the water, grabbed the ship, and raised it high enough so when it would let go, the ship would come out down and break the parts. It's not really true. But he did create a crane that would come out into a ship and rock it strong enough so it would tip over and sink. There is one occasion in which the Roman fleet was coming in. And on the beach, he lined a bunch of men up and put them in the shape of a parabola with mirrors in their hands. Maybe not mirrors like you and I have today, but polished sheets of metal Athens mirrors. And it is reported by Plutarch, the first great historian, that as one of the ships is coming in, when the Roman fleet decided they would try to embark on the Marines again, he lined them up, and the light came in, reflected off, tended straight to the focal point, which he lined up on the surface of the water where one of the ships is coming in. And since the ships were made out of wood, they could bust. It's argued whether that's true or not. What's that? What's that?
Mythbusters did it and they failed.
Yeah, somebody told me that. But mathematically speaking, what does that prove? I should say scientifically speaking, what does that prove?
They're not good.
See, I think scientifically it proves nothing. Just because someone tried to duplicate the experience didn't work. Doesn't mean it didn't work.
Yeah.
They did it on a really small scale too.
Or like focus.
Yeah.
And you know, it could have been, maybe it was like a very bright day, or a really good atmospheric conditions for it. And this is in the Mediterranean, right? You
It
get a lot
is
of
the
sun.
Mediterranean, yes.
Back on the summer.
So you guys, let me come back and talk about functions. I think I had an example like this last time, I can't remember.
It looks
Yes, you did.
familiar,
It was
but
number 7. So you had 2 numbers.
Well, yeah, whatever I did in class, I just made up, so I don't know what it said. With this surface, you guys don't graph it, let's just talk. Do you think you can plant your feet on the xy coordinate plane at any point in the xy coordinate plane and find a corresponding z value?
wait, so is this fxy going to give you something in terms of z?
Well, yeah, when I use the notation, the symbols f open parentheses, x comma y close parentheses, that's really acting as a z.
Okay,
Yeah.
I just want to be sure. Okay.
To get that shape, you could just do the traces of each.
Yeah, but we did that last time. I don't want to go there. I want to do something different. Well, do you think I can take a walk on the floor, which is xy coordinate plane, and stop, plant my feet anywhere, and see a corresponding z value above my head?
Yeah, because even if you have negatives, they're going to get squared and added together, so you'll get a positive
See,
value.
I agree. I do think that's true. As a matter of fact, I might even say in English that the domain of this function f is going to be,
All real numbers.
say it again.
All real numbers.
Say it one time.
Except for zero.
X and Y equals
All
0.
real numbers except for 0. No, because 1 over 0 would be.
That's wrong. Wait a minute. I'm talking about planting my feet in the Cartesian coordinate, in the xy coordinate plane. So what do you really mean by that?
So x and y can't be equal to 0, right?
Oh, so now you're talking ordered pairs.
X squared plus y
So
squared
you-
must not be equal to
So it
0.
can't be 0, 0.
Nice. I like that much better. How about notationally speaking, I say this. The domain is all of R2, such that I do not have this point. I can't write it, you guys, I'm sorry.
That's hard, I know.
It's not in.
We have to write it like that.
No, you don't. You can write it so many different ways. You guys, I'm just panicking and saying anyway what's convenient for me.
You should write it like that.
Right, it would mean it's all real numbers except for 0.
But I don't like when you say all real numbers because I'm really dealing with two-dimensional space.
And
All
and
points.
two space.
You could have said this. Is all order pairs x comma y such that x and y are not equal to 0, collectively speaking.
So what's your little E mean?
My little e means is an element of.
Oh,
So it stands for the phrase is an element of.
Strelga, I talked to Randall, and he said you could teach the symbolic logic lecture on Fridays, so.
Oh, gotcha. If you're interested in more symbols, I'll have a lot of Friday if you're interested.
What time?
1 o'clock,
One
right?
o'clock.
1 o'clock.
And where
Math.
at?
Calculus club.
323.
Got it, okay. That'll help.
Oh, you guys, my example's too easy. I change it. What if I had something like this? Oh, I never labeled it. What if I had z being equal to the square root of 1 minus x squared minus y squared? What can you say about the domain of that function? Yes.
So you have to like, you said equal to zero, set the inside chunk equal to zero, so you find out.
But why would you set it equal to 0?
I took a book to
Find out where. Maybe, well, you, actually, you know, this is pretty much irrelevant, isn't it? Because z could be any number. Z squared.
I'm too tired. Actually, if you square both sides, you're going to get a different number. Because going backwards, you have to square both sides, you get plus and minus components.
Oh.
So don't graph this thing, don't tell me what it looks like, I'm simply asking you this simple question. What's this domain?
All
It
reals.
looks like it could be all reals, because there's no point where it would be.
I just disagree with you.
Oh, no. X cannot be greater than y, or it cannot be less than y.
Oh, why is that?
No, wait.
The combination.
Oh, wait, you can't take the square root.
The
of
combination,
that
what was that?
Combination of x and y can't exceed 1 because they're both.
Yeah.
Nice, is that what you're
Yes.
about to say?
Yeah, you can't take the square root and get a negative number, because then you'll have imaginary numbers, and that doesn't work.
Thank you. You guys, I'm tired. I'm lazy, I don't want to do any of this. So let me just apply my math skills. If I'm going to take the square root of something, watch my pen. What the heck do I take the square root of? Has got to be greater than or equal to 0. Well, jeepers, if I bring x and y to the right-hand side, doesn't that tell me that x squared plus y squared is less or equal to 1? But jeepers, in words, and again, using math-y language, I think this is nothing more than all points that are
On a certain circle, right? No.
they're on the circle.
It would be a ball, right?
Or interior.
That would-
They could be interior as well. And so I think I've just got a ball in the
Yeah.
coordinate plane where the boundary is nothing more than the circle. And so graphically speaking, I think the domain looks like this. If I ask you to graph this domain, that's what I expect. If I ask you to give me the domain analytically, you probably write something like this. The domain is simply the collection of all ordered pairs x comma y such that x squared plus y squared is less or equal to 1. Maddie?
So the shading says it's a ball.
Yeah, I think the shading tells me it's really a ball or a disc, really. I use the word ball for 3 space. It's a disc where I'm including the boundary.
Well, you know that because it's a solid, right? It's a ball.
Yes, I agree.
Yeah.
Inequalities included.
In four-dimensional space, would it be a sphere then?
Yeah.
If we were to move this function out of one.
Yeah, I agree. So maybe I can say in English that the output of this function is another variable, therefore this equation represents a surface in 4-dimensional space because there are 4 variables. And I could even say that the domain of the surface in 4-dimensional space is nothing more than a collection of points in 3 space, such that I do not include the order. You guys see it? I don't like graph though, it's too difficult for graph.
So the trick is you're wanting to avoid having a 0.
In this example, yes, I was avoiding having a 0 downstairs, as opposed to my last example where I was avoiding having negatives underneath the square roots.
The book had an idea where it's like, you could like, because to graph like regular three-dimensional objects, you could do like level curves, that's what they called it, so you can do like level planes to graph them.
Well, how about saying level surfaces? I can get an idea what this 4-dimensional surface looks like by looking at the level surface in 3 space. I agree, that's what we typically do. An example like this would be really pertinent, say for example, talking about a temperature function, the temperature at any point in this room. That temperature would be my 4th variable. It's not necessarily a spatial example of 4-dimensional space, but it is an example of 4-dimensional space. We do mathematics in higher dimensional space all the time. It just doesn't have to be considered spatial, although as a mathematician, I don't reject that it's spatial, although some scientists do. You guys, help us with vocabulary. when it comes to a region like this in two space, I sometimes classify it, in this example anyway, my example number 2, I sometimes classify it as a closed region in two space. And here's the reason why. The points right here on the circle itself, I refer to as boundary points. And the reason why these are all boundary points, because no matter how small of a disk you create around those points in red, no matter how small it is, you're going to have points inside that disk that are both outside and inside that region. That's why it's a boundary point. And I will say in English that a region like this is closed in two space if it contains all its boundary points. Distinguishing boundary points and interior points. Interior points like this one with my other Christmas color. Here's an interior point because I think every single point that has a quality where it's positioned, every interior point has a quality that there's going to be some open disk containing the point, but completely inside my set.
And so that's true for sort of the splice square is strictly less than 1.
Yes, I would agree with that.
And then when x squared plus y squared is exactly equal to 1, then you've got a boundary.
Good. For the first one, you had your interior points. I like that. Oh no, my examples are too easy.
I'm still confused about 2 in 3 space, like so 3-dimensional shape, right?
Yeah, this is an example of a 3-dimensional surface. I was just asking a simpler question. I was asking you, what's this domain? Because I think we got a little bit of practice last time graphing 3-dimensional surfaces.
So is it a hemisphere, or what is it in 3 space?
Actually, you guys tell me, what does this thing look like in 3 space? What kind of surface is this?
Looks almost like a sphere, maybe, if you were to square both sides, but no.
If you square both sides, you would get z squared equals all that stuff inside, so it'd be like the,
X squared plus y squared plus z squared equals 1. That is a sphere. It's half.
You're right, that's a sphere, but what is this?
what about this hyperboloid thingy?
It's half of one.
Yeah.
It's a hemisphere.
Okay, now why can we say that? I'm sorry, I'm blanking out.
No, don't apologize. I like the way you talk. You said, oh, let's square both sides. Look at this. And let's go ahead and bring all the x, y, and z's to one side.
It would only be a sphere if z was either positive or negative,
Thank
but since z is
Because now
automatically
going
positive,
backwards
it's
to
a
get z
positive.
isolated, I have to take plus or minus the component square root, get those two individual surfaces above and below the xy coordinate plane, but I only had one. So it's the upper hemisphere.
Got it.
What about this example? So everybody question, sketch the graph of the domain of this function.
Is that a squared or a cubed on top?
Just a square. I think there's 2 problems here. One problem child is division by 0. The other problem child is making sure you don't take the square root of negative numbers. Yet again, if you're not getting entirely the same, look at our math skills. Let's address both those issues. I think to make sure that what I'm taking the square root of, this thing right here, is greater than or equal to 0, I'll set it greater than or equal to 0. And solve for x. I misspoke, didn't I? I meant isolate y. What do the collection of points look like? What do the collection of points look like satisfying this inequality?
You have a parabola, right,
Parabola.
that's filled upward on
Filled
the
upwards on
y-axis.
the
Yeah.
interior of it, I agree. Oh shoot, I messed up. I forgot the other problem child. So, also, I need to make sure that what the heck I'm dividing by is not equal to 0, but that's going to be true when y is not equal to negative x. So graphically speaking, what does my domain look like? Well, here's my x-axis. Here's my y-axis. I'm merely going to draw my parabola. And like you guys suggested, fill everything in. But show the reader I don't want the points on that line y equals negative x, so to the best of my abilities, with my red pen, I'll draw on the portion of the red line that passed through this region.
Negative, so yeah.
My apologies. I said y equals x in my head. I meant this. If
What?
you want to extend it, you can. I just don't think it's necessary.
Oh, okay.
And if it was in 4 space, it would be like a thing that could just like cut off of the plane.
Well, in 4 space, space, I think it makes my life more difficult to talk about domains, visually speaking, because I have to talk about some subset of R3 instead of some subset of R2, like in this picture.
Why is it still negative on that line?
Why is what?
Why is that the red line negative? It's slope.
Because it is over here.
Oh, I'm sorry, yeah, I got it. That makes sense.
What if I asked you this very simple question relative to what it says so far? Is number 5? What would this look like?
So,
Well, I'm not asking graph, I'm just asking for the domain.
so all you'd have to look for is in the denominator, it cannot be 0 or less than 0.
Greater than 0.
So I think I'm just satisfying this inequality. What does that look like?
That's a parabola.
Oh, my apologies, thank you, hold it. Is it less than or bigger than?
It's going to be, it can't be equal to, so that's right, yeah.
Wait, so y minus x squared must be less than or equal to 0, or
So
strictly
y
less than-
minus x squared has got to be strictly positive, which means y is strictly greater than x squared.
Why can't we take the square root? Oh, you're right, because we don't want a 0.
We don't want to divide by 0. What does that look like graphically?
You just have a parabola with the y region above the parabola shaded, or the inside region
But
shaded.
with no
yeah.
boundary points.
Yeah.
And what do I do with the line y equals negative x?
What, you don't have to do anything with it because
Yeah,
it can equal.
because if y is equal to negative x, no problem. Let's use output functions 0. It's still defined as a
Yeah.
Did you see it?
But you must not have points on that parabola above that.
So what would this look like in 3 dimensions?
Oh my
We have
goodness.
we have.
Actually, I just made this example up out of thin air. I think it's a pretty difficult example to conjure up, practically speaking. But you can do this. You can say, along this line y equals negative x, which by the way is part of the domain, along that line segment, I know all the z values of the surface are going to be 0. And I know I'm flaring up in a very asymptotic way along the boundary curve. Think of this boundary curve coming off the inboard, parallel to the z-axis. And take the same, we just go up definitely. I think the surface described by this function is curving up to that outer parabolic surface asymptotically. Because I think y equals x squared is the asymptote in higher dimensional space of the surface.
So this is just a cross-section in the xy plane of something that extends.
Yes.
So it's kind of like, so it's almost like having a parabola that extends infinitely,
Yes.
but with part of it sliced off along that line.
No, I think there's nothing sliced off. I'm just saying if I happen to live on that line, the z values are 0. But the closer and closer I get in the xy coordinate plane to this parabola, what happens to z values in the curve?
They're gonna go to infinity, right?
They're going to increase without bound. That's why I'm saying that cylindrical parabola is acting as an asymptote in higher dimensional space. Because if I were ever to plant my feet right on this parabola, the y values, the z values, would be undefined.
That's really hard to picture.
Oh, no, it's not. No, it's not. Just think of this as a wall coming up, and your surface getting closer and closer to it with really high z values.
Okay.
Could z could be negative then, correct?
Yes, it can. It can go on the other side. This cylinder is going in both directions, above the xy coordinate plane and below the xy coordinate.
So we're projecting that graph into the z.
Yes, I project it. That's straight up.
Can you justify making the z value 0 for that one point then?
Well, because if I'm on the line, y equals negative x, isn't that numerator equals
No, I totally agree with that, but I'm trying to imagine in my head what it would look like. Like that's where I'm having trouble. So we're projecting it out to infinity, but on that one portion of the parabola, the y equals x portion of the parabola, on that part, it's just gonna completely flat against the plane. Is that what we're saying?
on the parabola part.
Yeah.
Quite the contrary. I think as I move closer and closer in the xy coordinate plane to this parabola, my z values are increasing and decreasing without bound.
Oh, So it's almost like a boat shape kind of thing?
Not quite boat, because I think the cylinder is coming straight up the
Yeah,
infield,
that's
going
like
on
the
deck
arc.
parallel to the axis.
So there's no depressions, like an arc at all, it's just flat on top.
Or it's broad.
No.
Quite the contrary, this is a surface.
But,
It's a surface.
but that still didn't answer my question.
Which is?
So, the way I'm thinking about it, it has a depth, which is what that's the z-axis. But as we hit that y equals negative x line, the depth suddenly becomes 0.
Yes, thank
So,
you.
so it really just kind of goes like this, and then back like that.
And then through the ink board.
Yeah, exactly.
I agree.
So it's a parabola
I agree.
that gets smaller and smaller and it expands.
I agree.
Oh, that's cool. Okay.
And I think the portion of the surface that lives above the xy coordinate plane is simply the portion of surface that's above the line. The portion below the xy coordinate plane is a little bit of the portion of the surface portion is going to be below that line. So any point below that line that I raised in blue is going to have a z value that's going to be negative. Did you get it?
So what if you're terrible at visualizing this and you just want to draw traces in the x, y, x?
That's fine. Look at what I'm doing. I didn't even draw it. I'm just talking about the surface of space. And again, you guys, I'm being honest. I made this example a little bit there, and it seemed reasonable in my head in terms of domains, but I think it's a pretty sophisticated one graphically speaking. That's why I'm using words to describe it.
Sorry, can you-
That's okay.
I'm just kind of confused. Is something shrinking as it goes to infinity, or is it just kind of like consistent as it goes out? It's consistently not approaching that parabola.
I think the surface, if you're above this line, is consistently coming close to the parabola. The z values are increasing without bound consistently. It's just that if you look at any point in the xy coordinate plane below that blue line that I had in here, the line y equals negative x, I think the corresponding z values are all negative. And as I get a point in the domain getting closer and closer to that parabola, in that region, I think the z values are decreasing without bound. They're going through the wall towards negative infinity.
Oh, okay.
If you were to take
So what's-
the limit.
Sorry, what's the line?
Oh, whoa, whoa. I've got 15 minutes.
Well, you still have to hang out the quizzes.
Jeepers. Thank you.
Why did you ruin it for every?
You scared me. I will give you yours first. See, just totally
Thank you. I was worried you might not have it back, and so I wouldn't do my homework.
No, I felt so guilty last time, but no. James?
You didn't even grade it.
I did, well, I graded one place.
What?
I only graded one place.
Oh, okay.
But wherever it is in your book.
It's still, wherever it is. Oh my goodness.
Shoot, Rab. Joey?
I almost snapped the valley right. It still hasn't been graded. Don't snap around.
Bogdan.
The other one's like 1,000 days late.
So
I know, I'm still not getting one. Maybe qualities than just rectangular.
You know what's really cool? Later in the war, they changed the tips to be slightly pointed. And it gave it really nice characteristics at high altitude.
Okay.
Tony?
Well, because I can see where you, if you
Connor.
if you clip the tips on the wing, you get less drag. It's not like these things generate. So there's a certain point at which that becomes beneficial. But what I'm still going to get is why that shape.
Yeah.
You just get more area for given length.
I've been doing physics.
This is interesting. This is interesting to me because
No, this the real world application that went. So that's the whole problem.
Justin? Justin.
I wonder if like
I don't use it.
Ricardo.
Adam?
You were very welcome.
Well, yeah, I know about that. It's your
That's even higher.
is
Andrew?
right. Patty or the other guy? Pat and
Hell.
think you forgot.
That is my memory, it's Patty, yeah.
Patty or Tucker? Right there.
Andrew Tucker? Andrew. Sean?
Right, I know.
Are you guys ready for something else? You get to be honest with me. I need to know where you're at.
Where are we at?
You guys give me a show of thumbs. How many feel you had a really good solid introduction to the precise definition of a limit back in Math 30? Oh, really down?
Barachi was like an A++ teacher.
Awesome, awesome.
And she was good.
The guy I took, he was pretty good, right?
It'd be nice if we could just run him again really quick, just to refresh.
How if I do it in higher dimensions?
Okay, I'm good.
How about, we won't like ever have epsilon delta groups, will we? Because out of everything.
Ooh, when do we
out there,
do that?
That's like the one thing I don't.
When do we get to do epsilon delta? Today? We get to do it today?
Yeah.
Awesome.
You guys, you're making me nervous. I didn't mean, this is just something I
I
want
love
to
that.
discuss. I mean,
It's great. We did it in
we're
30.
talking about the test next week, right?
Yeah.
We have a test next week?
Don't we?
Yeah.
Yeah, next
Probably
Friday.
did.
What day? Next Friday. Friday?
Yeah, I tend to have on Fridays.
A week from can I like come to class early and then take it? You know?
But I'm in another class.
Can I take it like in the back of the class? I mean, I'm assuming there have been a few drops, so.
I have to do it for everybody.
Okay. It's just I don't want to show up late for work like I did last Friday.
So everybody, okay, I need some honesty. How many of you do need a background on this? Jeepers. All right. Forget my definition.
Wait, what are we working on right now?
We're going back to Math 30.
Math 3?
Math 30.
Saying it's way back.
Do you guys agree, at least on an intuitive level, that this is a true statement?
Yes.
Yeah, I think intuitively it's pretty clear limit of fx is, as x approaches a is equal to L in this picture, even though I'm adding something to it, because we don't really care what happens when it's back to A, right? So, I think I said it in a very clumsy fashion, and I don't want to be intuitive anymore. So let me maybe I'll rigor into my description of limits. I would like to say in English that if the limit of f of x is L as x approaches A, if I deviate from L by, how about epsilon units, either above or below, if that limit exists, I think this is what's true. If I draw a horizontal band to my curve, then I think there's some vertical band in blue that has equality, that deviating from A by no more than a certain number of units, like how about A minus delta and A plus delta, I'm guaranteed a y value that's within epsilon units of L. Now, I'm not being that sloppy. I know these points in blue and these points in red don't match up in my picture. I didn't want them to. Here's why. Because as long as in green, where these red lines hit my curve and then go straight down to the x-axis, as long as I'm deviating from A delta units in either direction and not getting past those vertical green lines, I think the corresponding y value will be within epsilon units of L.
So we are saying that delta is strictly less than epsilon in terms of absolute value? The absolute
Quite
value?
the contrary. I think what I'm suggesting is this. This position, in this position, I'll call them B and C. They're simply the positions on the x-axis that correspond to the y values in the curve, where y was equal to L plus 4 minus epsilon. I'm saying, as long as you choose delta to be the minimum, or excuse me, I misspoke. As long as you choose delta to be no more than the minimum of those two deviations, that's to say, A minus B, or C minus A, then you've got a delta value that'll work. I think if you choose x to be within delta units of A, like in this particular description, you're guaranteed a y value on the graph that's within epsilon units of M.
Okay,
But let me formalize this definition. This statement right here means the following. That for all epsilon greater than 0, there exists a delta strictly greater than 0 such that in absolute values, my f of x is going to deviate from L by no more than epsilon units whenever I choose x sufficiently close to A, or shall I say that x minus A in absolute values is less than delta.
Yeah, what's backwards E?
Backwards E.
Backwards epsilon, top right corner of the.
Oh, this just stands for the phrase such that?
No, not that one, not that one. Capital backwards.
Oh, that one. It's my existential quantifier. This stands for the phrase there exists.
okay, okay.
And here's my universal quantifier. It stands for the phrase for all or forever.
No.
Show up on Friday.
I'm gonna have to like learn these, because if-
Oh, yes.
I'm gonna be a math nerd, it's just.
Show up on Friday.
Back in Math 30, wasn't it?
Show up on Friday.
Sure, we'll do this on Friday.
I
Yeah.
work.
I'm sorry.
Well then, watch it on the internet. I'll post the
All
video.
math students, there exists some degree of insanity.
I'm still not understanding the Italian language scribble.
Let me rewind this when pointing to the paper. The limit of f of x is x versus A is L means for every epsilon greater than 0, there exists a delta greater than 0 such that in absolute values, f of x deviates from L by no more than epsilon units whenever in absolute values x deviates from A by no more than delta units. But it's a limit, so I do not care what happens when x is equal to A, so I've got another inequality here. So the game to play is find a delta that works relative to an arbitrary epsilon that's given to you. You guys, it's like my boss just pointed his head in the door and he's screaming at me. I do nothing but manufacture ball bearings. He poked his head in the door and screamed at me that today I've got to make a lot of ball bearings. And my ball bearings have to have a fixed volume of 1 cubic millimeter. And he's telling me if the volume deviates from 1 cubic millimeter by 1/10 of a cubic millimeter, I'm fired. So I go back to my machine that helps me create these ball bearings, and I'm panicking. Because my machine doesn't allow me to calibrate in terms of volume. It allows me to calibrate in terms, but only in terms of radius. So I'm sweating bricks at my machine, thinking, how am I going to create the corresponding radius, and how far can I deviate from the radius to guarantee the corresponding deviation in volume is no more than 1/10 of a cubic millimeter? What's L?
Your L is
1 cubic millimeter in volume. My epsilon is a tenth of a cubic millimeter. And my R is? My R is?
the radius is no. F of x? No.
I'm getting nervous. My R is, my
X is
my
your-
A is going to be 3 over 4 times pi.
I'm confused.
Well, the volume of a sphere is 4 times pi.
Okay, I guess I'm trying to take your real problem related to this.
The cube.
Yeah, I was I'm not seeing it.
So here's what I'm saying. My boss is screaming at me that my L value better be 1 cubic millimeter. But I can deviate from that volume by 1/10 of a cubic millimeter, so I think epsilon's going to be 1/10 of a cubic millimeter. But I got to go back to my machine and find out what corresponding radial distance gives me a volume of 1 cubic millimeter. That would be my A. But that clearly is just cube root of 3 over 4 times pi. And by the way, the delta is going to be how much I can deviate from that A value to guarantee me 1/10 of a unit from the positive 1 cubic millimeter. Which, by the way, I didn't do my head. I don't know what it is.
I'm still stuck on that E. What's that backwards E thing?
It's just a symbol referring to the phrase.
Backwards capital E.
This is my existential quantifier. It stands for the phrase there exists.
Okay, that is there.
You guys, I didn't make these symbols up. They're universal. We all use them. I was hoping you all used them since Math 30, correct?
Yeah.
Wait, hold on.
A little bit.
A little bit.
And that other backwards roll E, I'm sorry. This is just like new to me.
You mean this one?
Yeah.
It stands for the phrase such then.
So backwards little e with two dots means such that?
Yes.
Okay, so the
It's
dot.
not really E because this horizontal line goes through both sides of it. It extends both sides.
Kind of like a epsilon with something.
Yeah, it looks kind of like epsilon kind of root.
Can you explain why you're solving for R, for A, why you have the cube root?
Well, I think I needed to come to my machine and find a corresponding radial value that will give me a volume of 1 cubic millimeter.
And X is,
Well, X is anything. I just don't want to deviate from A by more than, because delta V is like different.
is X what you end up creating?
No, A is what it correspondingly found. Let me give you a more concrete example. What about this one? What if I told you that I got a curve that behaves this way? Hold on, you guys, I'm a little slow. Like this.
Do you think we're gonna get into three space?
I hope so.
We have like 5 minutes.
Well, can you at least show us a graph of what this would look like in 3 space before we go?
Yes.
Alright.
What's L?
11.
11. What's A?
It's going to be the distance from, or 5 is A. Sorry, 5 is A.
A is equal to 5.
Yeah.
What's my epsilon?
Your epsilon is, it looks like 0.2.
0.2 units. What's my delta?
Your delta, you have 2 delta values, right? So you have, well, you,
4.5
yeah,
and
because you have 4.5 and 5.1,
Wait,
which are
wait.
deviations away from x. So it's going to be 5.1 minus 5 and 5 minus 4.5.
Which one?
Both. They're both delta values. But it's going to be the lowest is going to be your
Thank you.
actual
That's
delta
the
value.
key. I want to be able to put some mathematical blinders on, plant my feet at 5, and not know which direction I go moving, left or right, and determine how far I can move left or right to guarantee me a corresponding y value with an epsilon units of 11. And so I think what I'll choose for my delta is simply the minimum of those 2 deviations. The deviation between 5 and 4.5, and between 5.1 and 5. But this is nothing more than
Oh, it makes sense.
the minimum of these 2 values at 0.5 and 0.6, but clearly that value is going to be 0.6.
That's how does.
Excuse me. I missed
0.5.
The minimum's going to be cheapest, 0.5.
That's how far you can go left or right.
Well, let's say it this way in English. If I deviate left or right by no more than that, then I'm guaranteed a y value within epsilon units of that.
Okay, so your epsilon in this case is 0.2 units, right?
Yes.
Okay.
I don't know.
5.1 minus 5.
Okay, so I can't do any arithmetic. What's 5.1 minus 5?
0.1.
I'm so sorry, you guys. Jeepers.
Yeah,
So that's 0.1.
makes more sense.
Okay.
So,
You know what's worse? I think there's another mistake. You know, I think technically speaking, this could be an inequality. I don't have to choose something that big, it could be smaller.
Okay.
So I think I had 2 mistakes in that mathematical statement.
so less than or equal to the minimum of your x value at the y that you want.
Yeah, I'm kind of nervous because you said less than or equal to, but it really is a strict inequality. Is that better, you guys?